Hello everybody, how's everybody doing? CRS here. This video will help you understand relative motion in a much better manner. So let's begin with understanding of relative motion in one dimension. So what is relative position? Now we need to understand that there is no absolute origin in this universe, which means there is no ultimate go-to reference point. So for everybody, you can have your own origin, and because of which the positions become absolutely relative. Let's try and understand it. Let's begin with this understanding. Here we have the floor, and let's talk about two men standing here. So that's person number one. Let me just call that person number one, and here person number two. There is both of these guys are standing, and the distance between them, let's say, is x is the distance between them. Now, if you ask person number one, person one would say that the person two is to my left and is at a distance x. But if you ask person two, person one would be towards right at a distance x. So you can write this in terms of a coordinate system. Now let us assume that this is positive x direction and that is positive y direction. Of course, the y direction would not be significant at this stage. We're talking about one dimension. When that is the situation, dear friends, we will now be talking about what is the position of the second person as seen by the first person. So this must be read as the position of second person with respect to first person, which means position of the second person as seen by the first person. So you have to write it as x2 minus x1. Now x2 minus x1, dear friends, are positions of the two men relative to the ground. You can say that this place is the origin O and this is at a distance x. Then all you can do now is ask what are these coordinates. X2, dear friends, is x, x2 is x can be, let's say, just for understanding, 50 meter, right? Let's assume that it's 50 meter. If it is 50 meter, then you would write x2 as 50 meter, because from observation you know that position of x1, position of person 1 is x1 and that's 0 meter. Position of second person is x2 and it turns out to be 50 meter. So if you were to see from the perspective of each of these two people, then you would do it this way. Now, position of the second person with respect to first person is x2 minus x1. It's 50 minus 0. The answer is a plus 50 meter, which means that when first person looks at the second person, then the second person appears at a distance of 50 meter in the positive x direction. That's what this plus sign basically means. Now going further, and if you ask me, sir, what is x12, or the position of first person relative to the second person with respect to the second person as seen by the second person, then you can write it as x1 minus x2. x1 minus x2. You know that x1 is anyway 0 meter for this example. So this is 0 minus x2, that's 50 meter. So the answer you get is a minus 50 meter, which means the position of the first person as seen by the second person is also 50 meter, but in the negative x direction. So this person will see person number one in the negative x direction, whereas the second person will be visible to the first person in the positive x direction. So this is how you convert a basic understanding of position into relative positions. Hoping that you have understood this, let's also talk about relative velocities. Once we understand that, the same can be extended to accelerations as well. Let us try and understand what is relative velocity. Relative velocity is the velocity of the other things as perceived by a given object. It could be a person, it could be whatever you want to choose with respect to a problem. Now, let's say that for a person standing here on the ground. So here is a person standing on the ground. There is this police car. Let's assume that this police car is moving with a velocity vc. and with respect to the person. That means when I don't write the other subscript, I don't write C after that, there's nothing. That means it is with respect to the ground. When that is the situation, here also we have a car, and this car is moving with velocity Vc, let us say. Or maybe this is police, so I shall write Vp. Vp is the velocity of the police car, and Vc is the velocity of this car. Then these are the two velocities as seen by this guy. Now the question is, how fast is that car moving as seen by the police car? It's a quite a common experience. If let's say you're driving on a highway, you will see the other person who's overtaking you with a very small velocity. But when the person coming from the opposite side on the other lane crosses you, it appears as if that person is driving really fast, because you are inside the car. Whenever you are inside the car, you will assume yourself to be at rest, and you will think that the other car is moving with the total velocity. Now that is the concept of relative velocity. Let's try and extend it to this with some examples. Watch. If you were to ask, what is velocity of the car with respect to police, then you can write it as velocity of the car minus velocity of police. That's the definition of relative velocity. Similarly, if you were to talk about velocity of police car as seen by the other car, would be equal to Vp minus Vc. Now what this means is, let's try and talk about it. Let's assume that this is positive x direction. So that's positive x direction. Let's assume that Vp is 20 meter per second and Vc is 15 meter per second, for instance, just to understand this better. Now, what is the velocity of the car as seen by the police? That's the question you're going to ask now. It is Vc minus Vp. Vc is positive. Why? Because this vector is in positive x direction. So you can write it as 15. And then you have minus. Vp is also positive. That's 20. So you write 20. The answer you get is minus 5 meter per second. What it means is that when the police sees a person driving in this car, this car will move in the opposite direction of this movement. Of course, the police car will not see itself moving. It will see the other car moving at a speed of 5 meter per second in the negative x direction. Why? Because this is going faster, 20 meter per second. This is going slower, 15 meter per second. So it is obvious that both of the cars are going to get closer to one another. When they get closer to one another, the distance between them is going to reduce, and this car will see as if this car is getting closer. So that's why the car sees a negative velocity. So that's the understanding of relative velocity. But let's talk about what is the velocity of the police car as seen by the other car. It is Vp minus Vc, my friends. Vp is 20 minus Vc, that's 15. You again get a 5, but with a plus sign. That means when this car sees the police car is coming towards this car with a speed of 5 meter per second. Now, this is the concept of relative velocity. Same can be also talked about with respect to acceleration. I'm sure that's not going to be a big deal. Let's now continue and solve a couple of problems based on whatever we have just now learned. Just to summarize how to do relative velocity, problems based on relative motion as such, you need to note down all the given parameters with respect to the ground. That's exactly, if you remember, what we did in both the cases with respect to the ground, a person standing on the ground. And then consider one object to be at rest and calculate the data with respect to that point, with respect to that body. So you either take the police car or you take the other car, for instance, in the previous example, and then you calculate everything with respect to that particular object. And once you do that, write all the relations and calculate the required data. This is something that I'll be showing you in the next example. Let's try to do that. Let's begin. A 120 meter long train is moving in a direction with 20 meter per second. So let us imagine that I have a train, and this train, dear friends, has got a velocity. Let me write that velocity as VA. Let me write that velocity as VA, and that is 20 meter per second. It's a 120-meter long train, right? It's a 120-meter long train. The question goes ahead and says a train B is moving with 30 meter per second in the opposite direction, and 130-meter long it is. So let's think about it. So we have another train which is a little longer, and it is here, right? It is here. It is 130-meter long, and it's traveling in the opposite direction with a velocity of 30 meter per second. Let me just call this velocity as VB. VB, my dear friends, happens to be 30 meter per second. In what time does the first train, long train, how long does it take for the long train to cross the shorter train? That's the question. So let's try to solve this problem, my dear friends. Let's try to solve this problem. We have got this particular train that is going to cross the other train. I want you to think about it. I want you to think about it. Now, you all have written these velocities, VA and VB. Both of these velocities are with respect to the ground. Both of these velocities are with respect to the ground. When that is the situation, you can now talk about how long it takes for this train to cross over. Maybe you should be sitting in, let's assume, this train. Let's say you're sitting in this train. You're sitting here. And when do you say the first train has crossed the second train? Right now you're here, and then it crosses. It's gone up till there. Now that's when you say it has crossed. So starting from here, the train has to go all the way to this place as seen by you. So I know that in reality, both of these trains are sort of moving in the opposite directions of one another. But I am saying sit here, right? I want you to sit here and then watch. You won't see your train moving. You will only see the other train moving. So the other train, my dear friends, will be visible to you as if it's moving this way. So you are seeing train A from train B. What is the total distance that train A travels with respect to train B? If you just assume, if you just think about it, starting from here, right now the distance is 0. It has to cover first 120 meter. Just think about this. And then it has to go another 130 meter. So that's how much distance it has to go in order to cross the complete train. So the total distance, or rather I'd like to say the displacement of the A train as seen by the B train is equal to 250 meter, because it's 120 plus another 130, right? It's 120 plus another 130. So that's the total distance that this train has to travel, because it starts from here, and from here to here it's 120, and then it again has to go another 130 meter in order to completely go to the other side of the train. That's the total distance you have to travel. And then you can also say the velocity of train A as seen by train B. Do you see that this direction is positive x direction? So the velocity of train A is positive, velocity of train B is negative. So it's a minus 30 meter per second. Let's try to compute that. This is VA minus VB. Dear friends, VA minus VB would be 20 minus of minus 30, which is 50 meter per second with a positive sign. That means the velocity of train A as seen by B is 50 meter per second in the positive x direction. You will see this train in moving in the positive x direction. When that is the case, dear friends, it's quite simple. You just have to find the time. Time is simply equal to distance divided by speed. Distance, you have the total distance that you have to cover is 250, divided by speed is 50, So you have 5 seconds, but 5 seconds is not one of the three options out there. So none of these is the correct answer. That's how you crack questions in competitive exam. That's how simple it is. So having understood this bit, my friends, let's go and try and solve another question. A police jeep is chasing with a velocity of 45 kilometer per hour. So here is a police jeep VP, and that's 45 kilometer per hour, right? So if you were to convert this to meter per second, you will have to multiply it by 5 by 18, and you will get 12.5 meter per second, right? If you convert it to meter per second. Anyway, and then a thief in another jeep is moving with a velocity of 153 kilometer per hour. So the velocity of the thief, dear friends, is equal to 153 kilometer per hour multiplied by 5 by 18 to convert it to meter per second once again, and that will be 42.5 meter per second. The police fires a bullet with the muzzle velocity of 180 meter per second. So when the police fires a bullet, he fires it with respect to him. So the velocity of the bullet with respect to police is 180 meter per second, my friends, right? That's the velocity of the bullet with respect to the police. The velocity with which it will strike the car of the thief is, we need to find what's the velocity of the bullet as seen by the thief, because whatever is the velocity the thief sees the bullet moving is the velocity with which the bullet will hit the thief who's moving, right? So we just have to figure this out, velocity of the bullet as seen by the thief. So let us write everything with respect to the ground first. That was the that was the thing that we learned in those 3 points. First, let's write everything in with respect to the ground. This is anyway with respect to the ground already. This is also with respect to the ground. This is one thing that's not with respect to the ground. We will try to write it with respect to the ground. Watch. So we have velocity of the bullet with respect to police is velocity of the bullet minus velocity of police. So what is the velocity of the bullet with respect to the ground then? Velocity of the bullet, velocity of the bullet with respect to the ground would simply be equal to velocity of the bullet with respect to police plus velocity of police. Now you will see that velocity of the bullet with respect to police is 180. So plus 180. In addition to that, velocity of police is 12.5. So I write 12.5. The velocity of bullet with respect to ground now is a positive 192.5 meter per second. So if the police and the thief are both moving in the same direction, obviously they're moving in the same direction, then when the bullet is fired from the police van, from the police jeep, the bullet with respect to the ground would be traveling at 192.5 meter per second. That's how you get the velocity of the bullet with respect to the ground. All that you have to do is find velocity of the bullet with respect to police. Velocity of the bullet with respect to police would be velocity of the bullet minus velocity of, I'm really sorry, you have to find velocity of the bullet with respect to thief. That would be velocity of the bullet minus velocity of the thief. Right? I think it's all now known. Velocity of the bullet with respect to the thief is velocity of the bullet, which is 192.5 minus velocity of the thief, that's 42.5. The answer you would get for the velocity of the bullet with respect to the thief is 150 meter per second. That's your answer. 150, dear friends, is option A. That's how quickly you can solve questions. I want you to sit down, draw a diagram, and imagine this scenario to logically, intuitively understand this. But this is how the math is done. It's absolutely simple. You practice this and you master it. But do remember, the day you stop growing is the day you start decaying. Thank you so much. I'll see you in the next video.